Bonjour, good afternoon. Here are my disclosures, none of them related to this presentation. So I was interested in working on cardiovascular disease and HIV over a decade ago when we started noticing in our clinic unusual numbers of patients with myocardial infarction. So we decided to do an administrative database study with the province of Quebec that was led by Madeleine Durand, who is in the room right now. Hello, Madeleine. And of course, we found what all the other studies found, that there was an excess risk of cardiovascular disease in people living with HIV. Now, people have a tendency to say life expectancy of people living with HIV is similar to that of the general population. But the reality is that life expectancy free of comorbidity is still lagging in people with HIV infection compared to those without infection. And, whoops. Oh, a little. And so we're interested in trying to understand why and what are the mechanisms, the pathophysiology behind this situation. So we know that inflammation is the driver of many chronic illnesses, and that if you have ongoing viral replication, at least at low level, you will have this chronic inflammation, which will lead to eventually several different premature aging phenotypes. We were interested in studying, in particular, IL-32, and I will tell you why. Okay, that's something I'm touching. That's not very good. Okay. So Mohamed El-Far in my lab, a senior scientist, was particularly interested in looking at this cytokine. Why? Because we were working on our long-term non-progressor cohort in Canada, and we had observed that some elite controllers were losing control of their infection. And we did a gene expression study before and after the loss of control of their infection, and we identified several genes that were associated with the loss of control, including IL-32. So this is the one that we decided to pursue further. IL-32 is a relatively novel cytokine discovered in 1992. It was called NK4 at the time. We know that it induces pro-inflammatory cytokines and that it is expressed by different cell types, including immune cells, but also non-immune cells, such as epithelial cell and endothelial cells. And we know that IL-32 is involved in different inflammatory conditions linked with aging and cardiovascular disease, such as COPD, rheumatoid arthritis, and others. And that IL-32 is upregulated in HIV infection as part of the antiviral response, and this is mediated by interferon-stimulated genes. So we decided to study IL-32 in the context of our Canadian HIV and aging cohort, which we created several years ago and is now led by a brilliant scientist, Madeleine Durand, who is a scholar from the FRSQ and an investigator of Canadian HIV Trial Network. And in order to enrich our patient population with women, we partnered with the WISE cohort in the United States with the collaboration of Robert Kaplan. So just a few words on the Canadian HIV and aging cohort. It is a longitudinal study up to 10 years, which is fully characterized in terms of the atherosclerotic plaque through very specific imaging studies and a complete immune profile. And the goal is to try to identify biomarkers that could predict early cardiovascular disease or identify potential therapeutic targets. We first showed that persistent upregulation of IL-32 is associated with loss of CD4 count and decline of the CD4-CD8 ratio. We also found that IL-32 correlates with soluble CD14 and IL-6, two very well-known biomarkers of cardiovascular disease. But the complexity of studying IL-32 is that it is expressed in multiple isoforms with diverse functions. Some are anti-inflammatory, some are pro-inflammatory, and they interact with each other. So we first look at the upregulation of specific IL-32 isoforms in HIV infected men with coronary artery atherosclerosis. And we found that some specific isoforms were upregulated in men, and they were IL-32 delta and theta. But to our surprise, when we looked at it in women, it was different isoforms that were upregulated, alpha, beta, and epsilon. And furthermore, when we look at the association between IL-32 and aging, IL-32 increased with age in women, but not in men. But we also have to note that in men, the level of IL-32 is much higher. We still don't understand these sex differences between this modulation of cytokines, and we are still working on this. So two of my graduate students, Rémi Brunet and Hardik Ramani, decided to look at the role of IL-32 isoforms in the functions of cells involved in cardiovascular disease. So first, we showed that IL-32 activates CD4 T cells and induces HIV transcription from latent reservoir. And this is mainly driven by IL-32 gamma. We then look at IL-32, its impact on cardiotropism of T cells. Cardiotropic T cells express a specific molecular signature, CCR4, XCR3, and c-Met positive. c-Met instructs T cell cardiotropism and promotes T cell migration to the heart. So what Hardik found was there was an increased frequency of these double positive CD4 T cell in response to IL-32. And the frequency of these double positive T cells was higher in HIV-infected individuals with cardiovascular disease. And this was probably mediated by IL-32 induction of CCL22 production, which is a ligand to CCR4. We know from work that has been conducted by our friend and colleague at the CHUM, Petronella Ancuta, that these double positive T cells are enriched in HIV DNA. And Hardik has been characterizing our cohort in terms of this enrichment for HIV DNA, and you can see his results in his poster EPA 016, which I invite you to look at. Furthermore, he has shown that IL-32 upregulates the expression of the heart homing receptor c-Met. So, to make the story short, homing of activated T cells to the plaque-forming sites in heart arteries is known to contribute to plaque destabilization and increases the risk of rupture and cardiovascular manifestation. Then we decided to look at the impact of IL-32 on coronary artery endothelial cells. And this work has been done by Rémi, who has shown that IL-32 isoforms differently impact primary coronary, that's a tough one for me to say in English, coronary artery endothelial cells chemokine production, and in particular CCL2, CXCL1, and CXCL8, and it is mostly IL-32 gamma and beta that are responsible. And these isoforms also impact endothelial cells monocyte recruitment. And IL-32 mediated chemokine production induces the recruitment of monocytes. And if you want to see the more complete work by Rémi on his transwell assays demonstrating this, please go see his poster EPB 093. And finally, we were also interested in looking at dysbiosis and subclinical atherosclerosis. We know that certain types of bacteria create a pro-inflammatory environment, and others have demonstrated that there is an enrichment of these bacteria in people living with HIV with coronary artery disease. We're interested in trying to find out whether there are some way we could use this to intervene in the IL-32 production and the chronic inflammation that ensues. So Mohammed demonstrated that there was an association between short-chain fatty acid and subclinical atherosclerosis, but in a positive way, he found that caproic acid diminishes IL-32 and other pro-inflammatory cytokines. So this opens up the door and eventually targets that we could use to counterbalance the chronic inflammation. So in summary, This is our model for now of the role of IL-32 in cardiovascular disease. First, we have this important gut damage that is caused early during acute infection, and that creates a loss of CD4 cells, particularly some subpopulation of Th17 cells. This creates microbial translocation, dysbiosis, which in turn upregulates the expression of IL-32 isoforms. And these isoforms, along with other pro-inflammatory cytokines, induces the migration of inflammatory macrophages and activated CD4 cells to the artery and contribute to the creation of the atherosclerotic lesion and plaque rupture. So, in conclusion, I would like to thank everybody that has cooperated with the Canadian HIV and Aging Cohort Study, in particular Madeleine Durand, our international collaborators, Alan, who is sitting here, Robert Kaplan, Jessica Castillo, which is a new friend that we will be working with, and in particular my research coordinator, Stéphanie Matt, and Laurie, Serge, and Tudor, who has been taking care of our patients all this time, and the funding organism, and I don't have the logo of the NIH, which is a big no-no, but they're there, and also my lab, and in the middle you see Annie Chamberlain, who has been my lab coordinator for decades and without whom I wouldn't be able to do anything. Thank you.